So now we're going to multiply some special binomials. They're called binomial conjugates. So I want you to see what they are. They have it so that they're the same, except one's a sum and one's a difference. Okay, so same terms otherwise, but one's adding and one's subtracting. So let me show you what happens when you multiply them. So this one's 4x plus 7 times 4x minus 7. Okay, so when we multiply, we want to multiply 4x times each of these two. So that's 4x times 4x, that's 16x squared, minus 7 times 4 is minus 28x, plus 28x, because now we're going to multiply 7 times positive 4, minus 49. And you'll notice these two in the middle, minus 28 plus 28, that happened because one was an addition and one was a subtraction, right? Okay, so what that's going to mean is it's going to disappear, because if you have minus 28 plus 28, it's gone. It makes 0. And you're left with 16x squared minus 49. That's what happens when you multiply conjugates by each other. The middle terms, that outers plus inners, if you think of this as FOIL, first, outers, inners, last, the outers plus inners always cancels away and makes 0. So it disappears. All right, so let's do a harder problem. Let's do part B. And I added in a C up here. I suppose we could do the C that I made up first. So let me work with that one first. So I made 2p squared minus 11r, or qr, I think it was. Yeah, minus 11qr times the same thing but with a plus. That's what makes them conjugates, is one's plus, one's minus, but the two terms are exactly the same. Okay, so this is going to be equal to, now 2 times 2 makes 4, p to the 4th, because you have 2 and 2 more makes 4. Minus, oh no, excuse me, plus 22 p squared qr minus 22 p squared qr, right? Because the outers is plus 22. 2 times positive 11 makes 22. Excuse me, 22 over here. And then the inners, negative 11 times positive 2 makes minus 22. And then otherwise it's the same, p squared qr minus 121, because 11 times 11 is 121, q squared r squared, because you have two q's. Oopsie. You have a q here and a q here. That gives you q squared. And then you have an r times an r, which is an r squared. So this is equal to 4p to the 4th. And then this middle term right here is going to disappear, because 22 take away 22 is gone, and you're left with 4p to the 4th minus 121 q squared r squared. Cool. So I added that one in. That was kind of new. All right, so then that leads me to the last one, which is 5x minus 3y times 5x plus 3y times 25x squared plus 9y squared. Okay. All right, now there are a couple ways you could tackle this, but the easiest is actually to get these two together, because a binomial times a binomial like that, when they're all the same, is kind of simple. So it's going to make 25x squared. That's 5x times 5x. 5 times 5 is 25. X times x is x squared. Then you're going to have a plus a 15xy, because 5x times 3y makes 15xy, minus 15xy, because a minus 3 times a positive 5 makes minus 15, minus 9y squared. And then this back one back here I haven't done anything to. Now again, this was not the only way to do this problem. This is just the fastest way, because what's going to happen is this is going to go bye-bye. Because you have plus 15, take away 15, that's all gone. Leaves you 25x squared minus 9y squared, and then times its conjugate right there. So you're still not done. Now you've got to multiply these two, and I don't need a computer for it, or as me parentheses for it. So 25 times 25 is 625, x to the fourth, right? Because you have x squared times x squared. You add the powers. 2 plus 2 makes 4. All right, 25 times 9 is 225. Oopsie. Plus 225 x squared y squared. Then you have minus 225 x squared y squared. Then minus 81 y to the fourth now. See, the x squared and the y squared, because they're different letters, you just write them x squared and y squared. But the y and the y, because of the same variable, you can add the powers and make it y to the fourth. All right, again, all of this is gone in the middle because these were conjugates of each other. I don't know if you saw that. It's 25 minus 9 and 25 plus 9. See that? They're conjugates as well, so again the middle terms are going to drop away. It leaves you 625 x to the fourth minus 81 y to the fourth. There we go. So it's kind of a little bit more complicated on that one. And again, that was not the only way to do that one. I just think it's the fastest way. And now we've learned something special about multiplying conjugates. When you take two binomials that are conjugates of each other and you multiply them, that middle term always disappears, right? So this whole thing, minus 28 plus 28, it goes away and it leaves you just the first term, oopsie, first term minus the last term. In other words, outers and inners becomes 0, right? And it's gone. All right, let me fill that in that box. Poof, there you go. Right, the product of the conjugates, it just becomes a squared minus b squared. Everything else disappears. All right, now let's take that newfound knowledge and let's expand it to doing this. Now, it says to write it in standard form. Now, remember, standard form, I'll remind you, is ax squared plus bx plus c. We learned that, back a few pages. That's standard form. In fact, I think that was the end of 6-1. Okay, there we go. Cool. So recall, I'm going to put a little recall there, right? There we go. All right, so we need to rewrite this into a better form than it is. All right. Is it minus 4 or plus 4? Yep, plus 4. Okay. So the first thing I'm going to do is I'm going to remind myself that, hey, when I see a binomial like this or anything like this squared with parentheses, I'm going to multiply it by itself. So that's x minus 3 times x minus 3. When I have more than one term like that, I'm going to write them out like that. Okay, so then this is equal to negative 2 times, now I'm going to figure out what this is, x minus 3 times x minus 3. Now those are not conjugates, so you're not going to get the middle terms to disappear on this one. X times x is x squared. So do the first one here times the first one over here. Then you do x times minus 3. So that makes minus 3x. Then you have minus 3 times x, that's inners, so that's minus 3x, plus 9, because minus 3 times minus 3 is plus 9. And then I still have this plus 4 kind of sitting out there. I haven't done anything with it, so I just leave it. All right, now I'm going to distribute. Oh, no, I'm not. Minus 2 times x squared minus 6x plus 9 plus 4. Now remember, that's that special property that we saw with perfect square trinomials back here a page, that it always becomes, see the 2, it's always double what a times b is. So if you look at your problem here, you've got a and b. A is 1, b is 3. 1 times 3 is 3, times by 2 you get 6, right? Because this was a perfect square trinomial right in here. All right, then now I'm going to distribute. That's negative 2x squared plus 12x minus 18, because you got to distribute that negative, plus 4, because you still have this plus 4 sitting out there. And now you just combine like terms. Plus 12x, oopsie, not underscore 12x, plus 12x minus 14. And we're done. Cool. Oops. Sorry, I just brought that back up just to help you see the steps. We wrote out what the squared was, then we foil's the bad way to remember it, but it's distributive property, right? You're multiplying that out. Then you just simplify, and you're done. Okay, so then I want to move up the product function definition, which should look very familiar because it's very similar to the sum definition that we learned back several pages ago here. Sum and difference, you just add or subtract. So the product, you just multiply, right? So it's handy that we know how to multiply these things now, right? All right, so I'm going to find f times g. And that really means I want f of x times g of x. So my f of x is equal to, oops, let me put it down here. It's equal to 2x minus 3 times 4x minus 7. There's my f of x times my g of x. All right, that's fine. Okay, so then I just have to multiply this out, distribute, right? FOIL, if you want to remember it that way. FOIL is just a way to remember it. That's all it is. So 2x times 4x makes 2 times 4 is 8, x squared, right? Because x times x, you add the powers, plus 2x times negative 7, oh, well, so minus 14x minus 12x plus 21. Right? Because minus 3 times positive 4 is minus 12. Minus 3 times minus 7 is plus 21. You do 2x times each of these, and then you do minus 3 times each of these. All right, then combine any like terms. You've got 8x squared minus 26x plus 21. And we're done. There's f times g of x. All right, so very similar to what we did before, but we multiplied. All right, now I'm actually going to throw you for a loop. I want to change this example here for B to negative 3 because negative 3 would be more difficult and we need to practice the things that are harder for us, okay? So I'm going to put in what f times g of x was. F times g of x was what we just found. So now I want f times g of negative 3. I'm going to kick it up a notch. I'm going to make it negative 3. So instead of writing x squared here, I'm going to write negative 3. Instead of writing that, I'm going to write negative 3. I know it makes it harder, but that's why I'm doing it. Okay. All right, so this is 8 times 9 plus, I think that's 78. Yeah, 78 plus 21, which is equal to 72 plus 78 plus 21, which is equal to 171. Again, I'm doing that with my calculator. Not with my calculator. I'm doing it in my head, but you can do it with your calculator. Oh, and in case you're wondering, if you really want to know, just FYI, f times g of positive 3, if you wanted to do that one, would be 15. So here, I'm going to type it up. There you go. So I'll just put it in there, which was the original problem, I know. But it was so easy. I thought throwing in a negative was always good for us, builds character. All right, we're done with that, and I'll meet you back here for the last video, which is going to be going over this story problem. So I'll see you then.